Hey everybody, so lesson 2.5, linear factors and multiplicity. This is section 2. This time what we're going to have is, we're given the zeros. They're given those to us. What we're going to do is basically work backwards from the previous section. In the last section, we had the function written in its factored form, and then we used the zero product property to solve that and find the zeros. This time, we're being given the zeros. We're going to use those to go ahead and write the function in its factored form. All right, so if I see that my zeros are 3, -2, and 0, I kind of have to think backwards and undo that sign. You know, if it's a positive 3, then my expression would be x minus 3. If you look back here, notice that we had the expression x minus 3. When it was set equal to 0 and we solved it, we had to do the opposite operation, or the inverse operation. And we added 3 to both sides, and that's how we got a positive 3. So what you're basically thinking is, x is equal to 3. Let me get that value moved back over here by changing the sign, and that way it would be set equal to 0, and it would say x minus 3 equals 0. The next one is -2. So if we said that x is equal to -2, then that means if you moved it back over here, it would become a positive 2. And so we could say x plus 2 is equal to 0. And then the last one, x equals 0. Well, even if you did move the 0 to the other side, and you get x plus 0 equals 0, well, you don't really need that 0 there. It's just simply an expression that would say x. So if I were to go ahead and write the whole function with all 3 expressions, this would be just a monomial, just x. So I actually want to put that one out front. And then in parentheses, I'll put the next expression, x minus 3. And then in another set of parentheses, put the other expression, x plus 2. And there we have a function written in its factored form. Over here, try it with this one. We've got x equals -3. And if we move that back over to the other side, we would get x plus 3 is equal to 0. Now, with fractions, here's where we got to be careful. We've got to do 2 steps, actually. X equals 1/3. See, a fraction is really just a division problem. So that means that you're going to want to do the opposite and multiply by what you have here for a denominator. So times 3 and times 3. And that would give you 3x equals 1, because it would basically cancel out the 3's right here, leaving you with the 1. Then we can take that 1 and move it back over to that side, just like we did these other ones. Only that 1 becomes a -1, and so we would have 3x minus 1 equals 0. And now I have my 2 expressions, and I can write my function of y equals an x plus 3 and also a 3x minus 1. And there we go.